Let's start with the 26th January MCQ papers of the Unit 2. So in this MCQ, the very first question, in this question what we can say is they are expecting the graph. So this is about current. So in this side we have current and this side we have voltage. So considering this thing, so we know here in this side there is no current, so that means in reverse current is not there, so this confirms that this is a diode. Question number 2. A phone is connected to a charger and the current is milliamperes, which gives you the charges. So we know I equals Q divided by T. So they're asking the Q, so we have I times T, which is 5 into milliseconds, so it's 10 to the power negative 3. 8 minutes is 60 seconds. So what we have is, answer is C. In the question number 3, they're talking about the energy levels. So we know the ground state is this. The electron in the ground state will absorb a photon. So since it's photon, it should be exact amount. Could not be. So we can see that they're asking for a could not be one. So if we check the A, okay, let's think from this to this. If you're going from here level to the other one, it should be the difference of these two, which is 10.2. And if it is from ground state to the level 2, then the difference would be 12.09. It's here to here, the gap would be 12.75. So we can see the 9.8 is a number which doesn't map any of either. So this is what it cannot be. Okay, now check the question number 4. In the question number 4, we have a circuit and they are saying the internal resistance is negligible. Light intensity incident on the LDR. So we know when the light sensor comes there in the LDR, what will happen is, here the LDR resistance will decrease. So we know the whatever the R you have, that will drop. So that means the total circuit resistance also drops. Because of that, the ammeter reading will increase because current is increasing. So this is correct. But if we think about the voltage is anyway, this is the only component in the system. So anyway, this 12 volt will be applied for this. So there will be no change to the voltage because it was entirely taken from this. So it will stay same. So the answer would be B. Now if we go to the question number 5, they're talking about two sources are in phase. The light has a wavelength of lambda, meets at a point P. The path difference is lambda divided by 4. Okay, we know lambda would be giving us the phase difference of 2 pi. So this is path difference and this is phase difference. If lambda is 2 pi, so we know lambda divided by 4 will give you 2 pi divided by 4, which is pi divided by 2. So the answer would be C. Okay, now for the question number 6, they're talking about the vibrating length of the string has, this is the mass and the length is given. So they are asking the speed of the transverse waves. We know speed equals T divided by mu, which is the mass per unit length. So we can take the mu in a separate place, which is mass per unit length 0.005 divided by 2.5. And since we need the T, we know the tension would be this. So this is the T value. So 20 divided by 0.005 divided by 2.5 root. So I'm writing it that way so that it will be easy. So when you know when it becomes multiplication, we take the reciprocal. So this would be 20 times 2.5 divided by 0.005. So which will be the answer as B. Thank you. And the question number 7. They're talking about the relationship between frequency and the lambda of a photon. We know V equals F lambda. So if I take the relationship, here the y-axis is F, so I'm going to subject F, V divided by lambda. So we know V is a constant. Since V is a constant, this is proportional to 1 over lambda. So if it is 1 over lambda, we know the graph is going to be D. This is how we see it. Okay, now the question number 8, they are asking about the potential difference across the length x. In this length x only they are asking us. So in this length x, what we can see is, we know resistance will be rho L divided by A. Since this is the same wire, resistance will be represented by actually length itself. So it's proportional because rho and A are same for the same wire. So what we can write is, for the voltage divided rho, so if we know this is R1 and the full resistance is capital R, what the voltage that we have is R1 divided by R times it by the full voltage. And we know R1 would be L, so if you want to put, I'll just put the rho L divided by A divided by rho sorry, here not the L, so it's the smaller one, so that is X. Since the R1 is corresponding to the smaller length, so that should be X. So if I write it here cleaner, so R1 is rho X divided by A, capital R is rho L divided by A. So here we have L divided by A times it by V. So we can see most of the stuff are getting chopped off, yeah, they are constants. So what we have is X divided by L times V. That is the voltage here. So according to that, what the answer we're going to get is X divided by L. Okay, now let's go to the question number 9. So in the question number 9, they're talking about reflections. So if it is reflection, we know we can use N1 sine theta 1 equals N2 sine theta 2. So I'll take a different color so that it will be more cleaner. So we know this angle, this is the refraction angle, so okay. But they are talking about a condition for total internal reflection. So if it is total internal reflection, now this is not how it will go. It will go like this, more than that. So this is the critical angle. So to become the total internal reflection, it has to be more than critical angle. So requirement is theta being greater than critical angle. So let's get the critical angle. So I'll consider N1, which is 1.75 times theta sine theta equals 1.40 times sine 90. Considering now the theta angle. So to be more clear, let me put it as sine C. So C would be, here it's 1.40 divided by 1.75, and sine inverse of that is the critical angle. So requirement is theta being greater than C. So theta being greater than this one, so the answer is 1. Okay, now the question number 10. So when longitudinal waves pass through the material, compressions and rarefactions are found. which row of the table is correct. Okay, now they're talking about pressure at rarefaction points. Okay, if it is compressions and rarefactions, we know the pressure will be minimum at rarefaction points. So it's easy to understand, because then if you talk about the compression, so if I take it compression, at a compression we know displacement is 0. So if I take about all the attributes, displacement will be 0. Because of that, only these two options. And if you talk about rarefactions and the pressure will be minimum at a rarefaction. So we know at a rarefaction that will be minimum. So answer has to be D. So we need to we need to know about what is the requirement of the displacement and compressions in each MCQs. Thank you.